There are stars we will never see, but they are there. This audiobook invites you to explore the hidden side of the cosmos, celestial bodies that do not emit light, that do not shine, but continue to shape the universe. Black dwarfs, failed stars, objects so faint that our instruments barely detect them. What does the sky hide from us, and how much of the universe is concealed in that darkness? A silent journey through the shadows of space, where the invisible also has a history. Dark matter is one of the first great enigmas to explore. It has been discovered that this form of matter does not emit light or energy that we can observe, but its influence is felt throughout the universe. Imagine that the universe is like a huge puzzle, and many crucial pieces are simply not in sight. Dark matter acts as the glue that holds galaxies together, even though we cannot see it directly. How have scientists concluded that it exists? Through indirect observations, such as the movement of galaxies and the way light bends when passing near massive objects. This leads us to question, what else are we missing? We cannot talk about the invisible without mentioning dark energy, another of the great mysteries of cosmology. This mysterious form of energy seems to be behind the accelerated expansion of the universe. Think of it as if you were inflating a balloon. At first, the air enters slowly, but then, as it continues to inflate, the pace increases. Dark energy is that breath that makes the universe expand faster and faster, but like dark matter, it is elusive and difficult to detect. What implications does this have for our future? Are we witnessing the universe separating into a vast and cold void? As we delve deeper into the topic, we encounter black holes, those mysterious giants that devour everything that comes too close. Although we cannot see them directly, their existence is revealed through the light that distorts around them and the influence they exert on neighboring stars. Imagine a huge whirlpool in the ocean that absorbs everything that approaches it. This is how black holes work, and their study not only teaches us about their nature, but also about gravity itself and its effect on space-time. Exploring beyond our solar system, questions arise about planets and moons that may be hidden in the vastness of space. How many strange worlds could exist orbiting distant stars without us ever having the chance to see them? The search for these celestial bodies is an exciting challenge that could change our understanding of the formation of the solar system and beyond. Human curiosity drives us to seek answers, to probe the unknown. Stars do not always shine in visible light. Some emit radiation in infrared wavelengths, which means they are invisible to our eyes. These stars, although they are there, we do not see them, but their energy can be detected with special tools. It's as if we had a spectrum of colors, but could only see yellow and blue, ignoring the red and green that are also present. How many wonders are there in the universe that we have yet to appreciate? Cosmic background radiation is another piece of the puzzle. It is a kind of echo of the Big Bang, a signal that speaks to us of the early moments of the universe. This radiation, although extremely faint, is fundamental to understanding how everything we know was formed. It's like a whisper in the midst of vast silence, indicating that there was a time when everything was different. What other echoes from the past might be waiting to be discovered? On a smaller scale, subatomic objects are invisible to the human eye, but their existence is crucial. These particles, which form the basis of all matter, remind us that what we see is only a small fraction of what truly exists. It's as if in a huge garden we could only see the flowers, while the roots, which are equally important, remain hidden beneath the soil. How does this affect our understanding of matter itself? Quantum physics, a fascinating and often perplexing field, also plays a role in our exploration of the invisible. In this subatomic world, the rules are different. Some objects can be simultaneously visible and invisible, depending on how we observe them. This challenges our notions of reality and leads us to ask, what do we really know about the universe? The search for exoplanets has revolutionized our understanding of the cosmos. Through ingenious techniques, scientists have been able to detect worlds that exist light years away, many of which are invisible to the naked eye. The way these planets affect the light of their host stars gives us the opportunity to glimpse what lies beyond our cosmic home. How many other solar systems are waiting to be discovered? Deep space is filled with phenomena that we cannot observe directly, such as distant galaxies whose light takes millions of years to reach us. As we explore these distances, we face profound questions about our own existence and place in the universe. Are we alone in this vast cosmic ocean, or are there other beings looking up at the sky, wondering the same thing? The light from distant stars also presents a dilemma. Although they may be bright, the immense distance and the expansion of the universe can make their light not reach our eyes. Sometimes what we see is only a fraction of what is really there. It's like observing a lighthouse from the shore. Sometimes the fog can hide its light even if it is present. What else is out there that we have yet to see? Hidden dimensions are another intriguing concept. Theories about the existence of additional dimensions suggest that our universe might be just a part of a much broader reality. Imagine a book with pages that you cannot see, but that contain stories and secrets that could change everything you think you know. What would this mean for our perception of reality? Relativity also impacts how we perceive objects in the universe. This principle shows us that time and space are flexible, meaning that what we see may depend on our position and movement. It's as if we had a clock that behaves differently depending on where we are. How does this affect our understanding of the visible and the invisible? Telescopy has been an essential tool in our search for the hidden. As more advanced technologies are developed, our ability to detect invisible objects expands. A modern telescope can open windows to parts of the universe that were previously inaccessible. What exciting discoveries await to be revealed through these new tools? Finally, gravity, that force we feel at every moment of our lives, also has the ability to reveal the invisible. The effects of gravity can attract and distort light, allowing us to glimpse what would otherwise remain hidden. It's a reminder that sometimes what we cannot see can be equally powerful. The exploration of the invisible is not limited to the cosmos. It also extends to our own world. Microbial life, although invisible to the naked eye, is fundamental to the health of the planet. These tiny organisms play crucial roles in ecosystems, reminding us that invisibility does not imply insignificance. Each discovery in the world of the invisible brings us one step closer to understanding the complexity of the universe and our place in it. So, as we embark on this journey through the invisible stars, let us remember that what we do not see can be just as fascinating and significant. Human curiosity drives us to look beyond the obvious, to explore the unknown, and to uncover the secrets that the universe has to offer. The path to knowledge is full of surprises, and each answer only leads us to more questions. In the end, who knows how many wonders await to be discovered in the vastness of the invisible? Dark matter is one of the great mysteries of the universe. Although we cannot see it, we know it is there. But how is that possible? What evidence do we have of its existence? To understand this, we must first think about how the universe behaves on a large scale. Imagine you are at a party and see a group of people dancing. If you cannot see someone pushing the dancers, but you notice their movement changes, what would you think? This is how dark matter affects galaxies and their movement. When we observe galaxies, we notice that they rotate at very high speeds. If we only considered visible matter, like stars and gas, these galaxies should fall apart. However, they remain intact. This suggests that there is something else, something we cannot see that keeps everything in place. That mysterious force is dark matter, but what is it made of? That is the question scientists have been trying to answer for decades. There are some theories about the composition of dark matter. One of the most accepted is that it is made up of subatomic particles that do not interact with light, which means they cannot be seen with our telescopes. Imagine trying to detect air in a room. You cannot see it, but you know it is there because you can feel it. Dark matter is similar. Its presence is felt through its gravitational influence. Additionally, there is a fascinating phenomenon called gravitational lensing, which helps us study dark matter. When the light from a distant star passes near a massive object, like a galaxy filled with dark matter, the light bends as if it were passing through a lens. This allows us to see objects that would otherwise be hidden. It's like having a special pair of glasses that lets you see through the darkness. The existence of dark matter has also been confirmed through studies of galaxy clusters. By observing how galaxies move within these clusters, astronomers have been able to calculate the amount of dark matter needed to explain their behavior. It's like counting how many people are in a room based on the sound they make, even if you don't see them. You can deduce their presence. One of the most intriguing questions is, how do we know that dark matter is not simply an error in our understanding of gravity? Throughout history, scientists have proposed various theories. But so far, the idea of dark matter has remained strong. There is no other explanation that fits the data we have collected better. Models of structure formation in the universe also depend on dark matter. Without it, galaxies could not have formed as they did. Imagine building a house without a solid foundation. It simply wouldn't stand. Dark matter acts as that invisible foundation that allows galaxies to cluster and develop. Some scientists have proposed that dark matter could be made up of particles called WIMPs, or weakly interacting massive particles. These particles are very difficult to detect, but experiments continue in search of evidence to support this theory. It's like trying to find a fish in a vast dark ocean where every attempt to catch it seems to fail. An alternative to dark matter is modified gravity theories. These theories suggest that the laws of gravity work differently on large scales. However, while they are interesting, they have not managed to explain all observed phenomena as effectively as dark matter. It's like trying to change the rules of a game to justify an unexpected outcome. Sometimes the rules are correct, and it is the context that needs to change. The study of dark matter is not just an academic exercise, it has practical implications. Understanding how the universe works as a whole could lead to advances in technology, energy, and much more. So why is it so difficult to detect? Dark matter does not emit, absorb, or reflect light. It's like a ghost in a room. We know it's there because we feel its presence, but we cannot see it. So far, we have explored dark matter through telescopes and simulations. However, the search for dark matter is also conducted in underground laboratories where experiments are performed. There, scientists attempt to create conditions that allow dark matter particles to interact with normal matter. It is an effort that requires patience and creativity, like trying to solve a puzzle with pieces that don't seem to fit at first glance. In the end, dark matter is a reminder that the universe is stranger and more complex than we can imagine. It invites us to look beyond the visible, to question our assumptions, and to be open to the unknown. As technology advances, perhaps in the future we will find answers that today seem out of reach. The search for dark matter is, in many ways, an exploration of the limits of our knowledge. Who knows what discoveries await us as we continue to delve into the secrets of the cosmos? What is the mystery surrounding dark energy? Even though we cannot see or touch it, this enigmatic force makes up approximately 70% of the universe. Its existence was proposed when astronomers realized that the universe was not only expanding but doing so at an ever-increasing rate. But what exactly is dark energy, and why is it so fundamental to our understanding of the cosmos? Imagine you are inflating a balloon. At first, the air you introduce causes the balloon to expand gradually. But what would happen if suddenly the balloon began to increase in size at an accelerated rate, as if an invisible force were pushing it from the inside? That is the essence of dark energy, a force that seems to be accelerating the expansion of the universe, but whose nature remains an enigma. Scientists have attempted to understand this mysterious energy through various theories. One of the most intriguing suggests that dark energy is related to the vacuum of space. In this context, the vacuum is not simply nothing, it can actually be filled with energy that causes the universe to expand. It's like an empty room that, instead of being a lifeless space, is full of possibilities. But how do we know that dark energy really exists? This is where observations play a crucial role. Astronomers have used supernovae, explosions of stars that shine brightly, to measure distances in space. By observing how these supernovae behave over time, they realized that the universe is not only expanding, but that the rate of that expansion is increasing. This discovery was a true turning point in modern astronomy. Dark energy also raises fascinating questions about the structure of the universe. Could it be that this energy influences how galaxies and galaxy clusters form? Some scientists believe so, and this opens up a range of possibilities about how the cosmos could have developed from its origin to what we see today. However, dark energy is not just an abstract concept. Its existence could have extraordinary implications for the future of the universe. If the expansion continues to accelerate, it could lead to a scenario where galaxies drift so far apart that, in a very distant future, we may no longer be able to see them. In a kind of heat death of the universe, everything would drift away until it becomes completely dark. And what about the relationship between dark energy and gravity? While gravity is a force that attracts objects, dark energy seems to be acting in the opposite direction, pushing the universe outward. This antagonism between forces is one of the reasons why dark energy is so difficult to understand. It's as if we have a cosmic tug-of-war in which both forces are fighting to define the fate of the universe. Scientists have proposed several models to try to explain dark energy. One of them is the cosmological constant, an idea that comes from Albert Einstein. Einstein, in his early theories of relativity, introduced this constant to balance the forces of the universe. However, he later set that notion aside. Today, the cosmological constant has returned to the conversation, raising new questions about the balance between gravity and dark energy. As we advance in our understanding of dark energy, we find ourselves facing an exciting and terrifying landscape at the same time. Could it be that in the future, dark energy becomes the key to understanding not only the fate of the universe, but also the secrets of matter and energy themselves? Research continues, and each new discovery raises more questions than answers. Meanwhile, the study of dark energy also invites us to reflect on our own existence in the vast cosmos. If an invisible force is influencing the expansion of the universe, what other invisible forces might be acting in our lives? Human curiosity drives us to seek answers, to explore the unknown, and to ask, what lies beyond what we can see? As technology advances, new methods are being developed to investigate dark energy. More powerful telescopes and experiments in particle physics laboratories are underway to try to unravel this mystery. The search is thrilling, and possibly the future of our understanding of the universe depends on it. In this journey into the unknown, each discovery about dark energy brings us one step closer to understanding the complexity and beauty of the universe. As we continue to explore, let us remember that the invisible is often as important as the visible. Dark energy is a reminder that there is much more in the cosmos than we can perceive with our senses. Ultimately, the quest for answers about dark energy is a journey toward the very essence of what it means to be human in such a vast and mysterious universe. There is a place in the universe where the rules of physics seem to fade away, a space where gravity is so intense that not even light can escape. This place is a black hole, one of the most mysterious and fascinating entities that exist in our cosmos. But what exactly are black holes? To understand this, it is essential to first talk about how they form. When a massive star exhausts its nuclear fuel, it can no longer hold itself against the gravitational force pulling it inward. At that moment, the star collapses in on itself, and if it is large enough, it can become a black hole. This collapse generates infinite density at an extremely small point known as a singularity. Around it, an invisible boundary forms called the event horizon. Once something crosses this limit, there is no turning back. Can you imagine being trapped in a place where you cannot escape its pull? This phenomenon raises fascinating questions. How do black holes behave? Despite their dark nature, we can infer a lot about them from their effects on the surrounding space. For example, if a black hole is in a stellar system, it can attract other stars toward it. As these stars approach, they begin to spiral in, creating a disk of bright matter around it. This disk emits radiation in the form of X-rays, which we can detect from Earth. Thus, although we cannot see the black hole itself, we can observe its influence in its cosmic neighborhood. Isn't it amazing how the invisible can reveal so much? Black holes also come in different sizes. There are stellar black holes, which form from the collapse of individual stars, and supermassive black holes, which reside at the heart of almost all galaxies, including our own, the Milky Way. It is believed that these supermassive black holes can have millions or even billions of times the mass of the Sun. How did these giants form? The answer remains a mystery, but scientists believe they may have been created from the merging of smaller black holes or from the accumulation of gas and stars at the centers of galaxies. The study of black holes also challenges our notions of time and space. Einstein's theory of relativity tells us that gravity can curve space-time. This means that near a black hole, time slows down compared to a more distant location. Imagine having a clock at the edge of a black hole and another on Earth. While time on Earth continues normally, for the clock near the black hole, time passes more slowly. This phenomenon is known as time dilation and has fascinating implications for our understanding of the universe. In addition to their effect on time, black holes can also swallow material. When an object, such as a star or gas, gets too close, it can be devoured. This process is not only lethal for the object, but also generates a tremendous amount of energy. Scientists have observed jets of particles being expelled at speeds close to that of light from the poles of some black holes. What kind of energy is released in these events? The existence of black holes raises intriguing philosophical questions. If a black hole can swallow information, what happens to it? According to quantum information theory, this information is not lost, but its nature is an enigma that we are still trying to unravel. This debate has led to the idea that black holes could be portals to other universes or dimensions. Could these mysterious objects be the key to understanding the nature of the multiverse? In our quest to understand black holes, we have developed advanced technology to detect them. X-ray telescopes and gravitational wave observatories have allowed us to observe the universe in ways that were previously unthinkable. This advancement has led to astonishing discoveries, such as the image of the black hole at the center of the M87 galaxy, captured by the Event Horizon telescope. What other secrets will the universe reveal to us if we continue exploring? The importance of black holes in the cosmos is not limited to their ability to absorb matter. They also play a crucial role in the formation of galaxies. It is believed that their gravity can influence the distribution of stars in their surroundings, thus affecting the evolution of galaxies. Could these invisible giants be the architects of the universe as we know it? As we delve deeper into the study of black holes, it is essential to remember that, although they are invisible to our eyes, their impact is undeniable. They teach us about gravity, relativity, and the complexities of the universe. They challenge us to think about what we know and what we still have to discover. Human curiosity drives us to seek answers in the unknown. In summary, black holes are more than mere cosmic entities. They are bearers of questions and intrigues that challenge our understanding of reality. As we continue to explore the universe, each discovery about these mysterious objects brings us one step closer to unveiling the secrets of the cosmos. The adventure of science never ends, and every answer generates new questions. What else will the universe reveal to us about black holes and their role in the vast and enigmatic dance of the cosmos? The search continues. Is it possible that there are still hidden planets and moons in our own solar system? The answer is an intriguing yes. As astronomy advances, we realize that the universe is vast and full of surprises. Sometimes what we cannot see can be as fascinating as what is visible. Imagine you are on a beach, and although the sea seems calm, powerful currents may exist beneath the surface that you have yet to discover. This is how it is in our solar system. Theories suggest that there could be celestial bodies in places where we have not looked closely enough. For example, there is talk of a ninth planet, nicknamed Planet 9, which could be orbiting in the farthest reaches of the solar system. This planet, not yet directly observed, could be several times larger than Earth. How is it possible that something so large has escaped our notice? The answer lies in distance and brightness. The farther away an object is, the harder it is to see, especially if it does not emit its own light. Now let's think about moons. Did you know that there are moons that could be orbiting planets in distant solar systems? Or that they could even exist around planets we have not yet discovered in our own cosmic neighborhood? The possibility of hidden moons adds an additional layer of mystery to space exploration. These moons could hold clues about the formation of our solar system or even about the possibility of life in extreme conditions. Detection techniques have advanced significantly, but they sometimes rely on the gravity of massive objects acting as lenses, distorting the light from more distant bodies. This is called gravitational lensing. Can you imagine an object so large that it can bend the light of other objects and reveal them to our eyes? This is how some of these yet-to-be-seen moons or planets could be detected indirectly. The idea that a celestial body is hidden behind others is fascinating. Think of a game of hide and seek. Sometimes the best hiding spots are the ones closest to those who are searching. This is what might be happening with unobserved planets and moons. Detecting these objects is not always straightforward, as it requires advanced technology and careful analysis of data. Astronomers are also searching the far reaches of our solar system where there is less light and more cold. Space probes have sent valuable information about the outer planets. But there is still much to discover. Each new finding could change our understanding of planet formation and the history of the solar system. It is not just about searching for new worlds, it is also about understanding how they form and evolve. What conditions make a planet capable of harboring life? What types of interactions do celestial bodies have with each other? Each answer to these questions brings us closer to unraveling the mysteries of the universe. Moreover, the search for undiscovered planets and moons is not limited to our solar system. In other stellar systems, astronomers are discovering worlds that challenge all our previous notions. Some of these planets are so different from Earth that they make us question what we know about planetary formation and the possibility of life elsewhere. As we explore what lies beyond the known, human curiosity continues to drive research. The search for new celestial bodies is a never-ending journey, and each new discovery raises more questions than answers. What other wonders are hidden in the vast universe? It is fascinating to think that at this moment there may be worlds waiting to be discovered, not only in our solar system but in the far reaches of the cosmos. Science progresses, and each day a new window to the universe opens. The quest for the invisible reminds us that there is always more to learn and explore. In the end, the idea of undetected planets and moons invites us to look beyond the obvious. It teaches us that what we do not see can be as important as what is around us. The stars that shine in the sky are familiar to us, but there is a hidden world of wonders waiting to be revealed, and each of us has a role in this endless pursuit of knowledge and discovery. Curiosity and the desire to explore the unknown are what drive us as a species. The next time you look at the sky, remember that what seems empty might be full of secrets yet to be discovered. In this vast universe, there is always more beyond the visible, and that is what makes space exploration so exciting. The adventure has only just begun. The stars that shine in the sky are just a small part of what really exists in the universe. But did you know that there are stars that are invisible to our eyes? Throughout the history of astronomy, scientists have found ways to detect and study these hidden stars, which emit their light in wavelengths that we cannot see. This leads us to a fascinating question. What secrets do the stars in the infrared reveal to us? Stars that emit light in the infrared are celestial objects that, although they do not shine with the intensity of their visible counterparts, are essential for understanding the formation and evolution of the universe. Imagine you are in a dark forest on a moonless night. Even though you cannot see everything around you, you know that there is life surrounding you. Similarly, in the vast cosmos, the stars in the infrared are there. But we do not see them with our naked eyes. Why are infrared stars so special? The answer lies in their temperature and life phase. The cooler and less luminous stars, such as brown dwarfs, primarily emit in the infrared. These stars are like the missing pieces of a cosmic puzzle, helping to complete the picture of how stars form and evolve. If we only look in the visible spectrum, we are missing a crucial part of the stellar story. Moreover, stars that are in the earliest stages of their formation are often surrounded by dense clouds of gas and dust, which absorb visible light. Only by observing in the infrared can we see through these clouds and discover new stellar systems that are forming. It's like looking through a heavy curtain to see what's behind it. Without infrared, many of these stars would remain hidden forever. And what about distant galaxies? When we look far into the universe, we are not only seeing the past, but also witnessing how the expansion of the universe affects the light from stars. The light from distant stars can be so redshifted that it becomes infrared. So by studying the infrared, we not only discover more stars, but also gain a better understanding of the history of the cosmos. Technology has advanced impressively to help us explore these invisible stars. Telescopes like the Hubble Space Telescope and the more recent James Webb Space Telescope have been designed to observe in infrared wavelengths. These instruments are like our enhanced eyes, allowing us to capture light that previously eluded us. Thanks to them, we have been able to discover new worlds and study star formation with unprecedented clarity. In a broader sense, the study of infrared stars also helps us understand the evolution of our own galaxy, the Milky Way. By observing the infrared light emitted by gas and dust in the galactic disk, astronomers can map the distribution of these materials and understand how new stars form in different regions. It's like having a map of hidden roads that guides us through a constantly changing cosmic landscape. But it's not just about stars in the infrared. This type of light can also reveal other phenomena, such as the presence of forming planets around young stars. Infrared light can penetrate clouds of gas and dust, allowing us to see how these planets are being born. So by studying the infrared, we are not only getting closer to the stars, but also to the worlds that may exist around them. The fascination with the invisible is not limited to astronomy. It reminds us that there is much more in the universe than we can perceive. Infrared stars are a reminder that we must expand our senses, look beyond the obvious, and question what we think we know. Each discovery in the infrared spectrum brings us a little closer to understanding the vast and mysterious universe we inhabit. It is worth mentioning that infrared light is not just an astronomical phenomenon. It also has applications in everyday life. For example, infrared cameras are used to detect heat and are utilized in various technologies from night vision devices to thermometers. This demonstrates that what we learn from the stars can also have a direct impact on our lives here on Earth. The mystery of infrared stars does not stop there. As technology advances, new doors open for exploration. More powerful telescopes and more sophisticated techniques will allow us to delve deeper into the exploration of these hidden stars and possibly discover new phenomena that will change our understanding of the cosmos. In summary, infrared stars are a fascinating aspect of astronomy that invites us to look beyond the visible. They remind us that the universe is a place full of surprises and that sometimes what we cannot see is just as important as what we can. Each new star we discover, each new system we explore, brings us one step closer to unraveling the secrets of the cosmos. So the next time you look at the night sky, remember that there is much more than meets the eye, and that invisible stars are waiting to be discovered. Cosmic background radiation is one of those fascinating mysteries that whispers secrets about the origin of the universe. But what is it exactly? It's like the echo of a gigantic explosion, the one that gave rise to everything we know. This radiation manifests as a kind of faint light that floods all of space, a whisper coming from very distant times just after the Big Bang. Isn't it amazing to think that this light is a remnant of the cosmos's infancy? Imagine you are in a dark and cold desert. The night is deep and serene, and as you look up, the sky is filled with stars. But amidst all that beauty, there is a background that seems to glow with a subtle radiance. That is the cosmic background radiation, a light that is not visible to the naked eye, but is there enveloping everything in an almost imperceptible embrace. Its discovery was a milestone in astronomy. revealing that there are not only stars and galaxies, but also a rich history behind them. Where does this radiation come from? It originates from a time when the universe was a hot and dense place, a true cauldron of particles and energy. Over time, as the universe expanded and cooled, this energy transformed into what we see today as radiation. It's like a wind carrying the echoes of a distant past, allowing us to hear the symphony of the cosmos. In 1965, two scientists, Arno Penzias and Robert Wilson, stumbled upon something extraordinary while working on a communication project. They heard a kind of persistent noise that they could not explain. After investigating and ruling out all possible interference, they realized they were capturing the cosmic background radiation. This discovery earned them the Nobel Prize and also provided us with one of the first tangible pieces of evidence for the Big Bang theory. But how has this radiation persisted over billions of years? The universe is not a static place. Although it is expanding, the cosmic background radiation has traveled through space for billions of years and has retained its imprint of what it once was. This phenomenon is a reminder that, despite the vastness of space, there are connections between who we are today and what the universe was like in its infancy. This cosmic echo not only speaks to us of our past, but also offers clues about the future. Did you know that this radiation is almost uniform in all directions? This means that no matter where you look in the sky, you will receive a small ray of that ancient echo. It's as if the universe is speaking in a soft tone, revealing its secrets to those who take the time to listen. But what does it really tell us about the structure of the universe? The temperature of this radiation is approximately 7 degrees Kelvin. An extreme cold that might be surprising. But why is this temperature important? It indicates that the universe has cooled significantly since its birth. It's as if the cosmos has gone through an immense cooking process. And now, what was once a boiling broth has become a vast and cold space. Cosmic background radiation also provides information about the amount of matter and energy in the universe. Through its study, scientists can estimate the density and composition of the cosmos. This is crucial because it helps us understand how galaxies and the structures we see today have formed. It's like a puzzle where each piece fits together to reveal the story of the universe. Some might wonder, what about the future? Cosmic background radiation can also give us clues about what is to come. As the universe continues to expand, this radiation will keep cooling and evolving. At some point, could it become a distant memory of what was once a vibrant and life-filled universe? Moreover, the study of this radiation has led to the creation of tools and technologies that have changed the way we observe the cosmos. Modern telescopes and satellites are capable of capturing this faint light, allowing us to explore beyond what our eyes can see. It's like opening a window to a hidden world that has always been there, waiting to be discovered. Cosmic background radiation reminds us that the universe is full of surprises and mysteries. Every time we look up at the stars, we are not only observing light, but also the trace of a story that has been unfolding for billions of years. It is a journey through time, where each flash of light is a page in the book of the cosmos. In conclusion, cosmic background radiation is not just an interesting phenomenon. It is a testament to our existence in a vast and ever-changing universe. It invites us to reflect on our place in the cosmos and encourages us to keep exploring, learning, and discovering. After all, each new finding brings us a little closer to understanding the mysteries that surround us. Who knows what other secrets might be waiting to be revealed in this vast and mysterious expansion of the universe? What truly composes the universe? Often when we think of the matter around us, we imagine visible objects like stars, planets, and perhaps even a couple of asteroids. But here's an intriguing fact. Most of the matter in the universe is completely invisible. We are talking about subatomic particles, those tiny entities that are fundamental to the very existence of everything we know. But why are they so important if we cannot see them? Consider the idea of a large puzzle. Each piece represents a part of the universe, but some of those pieces are invisible to the naked eye. Physicists have discovered that much of the matter in the universe, known as dark matter, does not emit light or energy, making it undetectable through conventional methods. However, even though we cannot see it, its existence becomes evident through its gravitational influence on visible matter. Isn't it fascinating to think that something we cannot see has such a huge impact on what we can observe? And what about dark energy? This mysterious force seems to be behind the acceleration of the universe's expansion. Although we cannot detect it directly, its effect is felt across the vast distances of the cosmos. In this sense, dark energy could be seen as the engine of the universe driving its continuous growth. But how is it possible that something so powerful remains hidden, like a giant concealed in plain sight? Subatomic particles such as electrons, protons, and neutrons are the heart of matter, but there are many more particles that we do not see, like neutrinos, which are so elusive that they pass through the Earth without leaving a trace. This leads us to wonder, what other secrets does the universe hide through these invisible particles? The reality is that, although they are invisible, they are crucial for understanding how matter works as a whole. Imagine an ocean of particles floating around us, invisible yet omnipresent. These tiny entities are responsible for the fundamental interactions that shape everything we see. However, their elusive nature raises profound questions. What other forms of life, matter, and energy might exist in this vast ocean that we have yet to discover? As we delve into quantum physics, the world of the subatomic becomes even more intriguing. Here, reality challenges our intuition. Particles can be in multiple places at once and can behave in ways that seem strange to our everyday experiences. This raises the question, is it possible that there are more dimensions in the universe that we cannot perceive due to our physical limitations? Perhaps there are aspects of reality that are invisible to us but play a key role in the fabric of the cosmos. Moreover, the study of subatomic particles has led to technological advancements that impact our daily lives. From medicine to computing, discoveries in this field have had a profound effect. But what if we could see these particles? Imagine a device that could make the interactions of these tiny entities visible. How would that change our understanding of the world around us? The search for invisible particles does not stop in our solar system. In laboratories around the world, scientists are working to detect and study these particles in order to unravel the mysteries of the universe. But what challenges do they face in their quest? Detecting subatomic particles requires extremely advanced technology and specific conditions, making their study a monumental task. The history of physics is also filled with surprising moments related to the invisible. In the past century, quantum theory challenged traditional notions of classical physics, revealing a world where invisibility becomes a commonplace phenomenon. What implications does this have for our understanding of reality? Perhaps what we consider real and visible is just the tip of the iceberg, and so we find ourselves in a universe full of mysteries. Subatomic particles, although invisible, form the basis of everything we know. Quantum physics, with its strange and intriguing properties, leads us to question our perception of reality. What does it really mean to be visible? It is a concept that goes beyond simple observation, opening a world of possibilities that we are just beginning to explore. The invisibility of certain objects and particles invites us to reflect on what we have discovered and what is yet to come. With each new advance in science, we get a little closer to unraveling the secrets of the universe. But the journey does not end here. As we look to the future, curiosity and research remain our best tools for understanding what is still invisible. Finally, the question lingers: what other secrets of the universe remain hidden from our sight? The invisible is not just a matter of lack of light, it is an invitation to expand our minds and explore the unknown. In every corner of the cosmos, wonders may be waiting for us that, although invisible, are fundamental to existence itself. The search for the invisible is ultimately the search for knowledge and understanding of our place in the vast universe. Quantum physics is a fascinating realm full of mysteries that challenge the logic we use in our daily lives. What if I told you that there are objects in the universe that can be invisible not because they don't exist, but because they obey completely different rules? To understand this, we must first dive into the subatomic world, where particles are like small actors on a stage that doesn't always behave the way we would expect. In the classical world, we are used to seeing things in a very concrete way. If you throw a ball, you see it follow a predictable trajectory. But on the quantum scale, particles can be in multiple places at the same time, as if they have a kind of double life. This strange property is called superposition. Imagine you have a coin. In the classical world, when you toss it, it will land on heads or tails. However, in the quantum world, before you look at it, the coin can be in a state of heads and tails at the same time. Only when you look at it does it decide which state it remains in. This idea may seem like something out of a science fiction novel, but it is the reality that governs subatomic particles. Now, what does this have to do with invisibility? One reason certain particles or phenomena are not visible is precisely because they interact with light in ways we cannot see. For example, neutrinos are subatomic particles that are incredibly difficult to detect. They pass through matter as if they are moving through air, barely interacting with it. A stream of neutrinos can pass through an entire planet without being stopped. This makes them invisible to us, even though they exist in large quantities. To visualize this, think of a fish swimming in a dark ocean. Although it is surrounded by water, the fish can be almost invisible to a hunter on the surface, as light does not reach the depths where it is located. Similarly, neutrinos and other subatomic particles move through our world, but without leaving a trace, making them specters in the vast network of matter. Continuing with this idea of invisibility, we also find that electrons behave in a way that defies our everyday logic. Instead of orbiting around the nucleus of an atom like planets around the sun, electrons occupy clouds of probability. This means we cannot say exactly where they are at any given moment. We can only calculate the probability of finding them in a certain area. This uncertainty is part of the essence of quantum mechanics. So, in a sense, these electrons are invisible, as we cannot locate them precisely. What about photons, light itself? In some circumstances, photons can be absorbed or reflected, making certain objects appear invisible. Imagine a chameleon that adapts to its environment, changing color to avoid being seen. In the same way, some particles can camouflage themselves in their quantum environment and therefore do not catch our attention. The key question is, how do we know these particles exist if we cannot see them? This is where experiments come in. Scientists have developed ingenious techniques to detect what we cannot see. For example, when one particle interacts with another, it can produce effects that leave visible traces, like a trail of light in a bubble chamber. Thus, even if we do not see the particle itself, we can infer its existence from what it causes in its environment. Quantum interference also plays a fundamental role. When two particles meet, they can interfere with each other, creating patterns that are visible, even if the particles themselves are not. It's like a light show on a dance floor. Even if you don't see the stars at night, the glow in the sky can tell you stories about what is happening in space. Wave-particle duality is another key concept. Particles like electrons can behave both as discrete particles and as waves that propagate through space. This duality allows certain phenomena to be invisible to us, as they can disappear into a wave of possibilities rather than being a concrete entity we can observe. Thinking about this, an intriguing question arises. If there are so many invisible things, what else is the universe hiding from us? Quantum physics shows us that what we consider real is just a small part of a much larger puzzle. Each discovery opens the door to new questions. Are there dimensions we cannot perceive? Are there particles we have yet to detect? Human curiosity is insatiable, and each answer leads us to more questions. Technology also plays an important role in our quest for the invisible. Particle accelerators are tools that allow scientists to collide particles at high energies, creating conditions similar to those that existed just after the Big Bang. In these extreme environments, it is possible to observe phenomena that would otherwise remain hidden. Each collision is an opportunity to unveil secrets that have been concealed for millennia. What if I told you that invisibility is not just a scientific phenomenon, but also a concept related to our perception of the world? What we see and what we do not see often defines our understanding of reality. Quantum physics challenges us to reconsider our notion of the visible and the invisible, and invites us to explore beyond what our eyes can capture. In conclusion, quantum physics offers us a window into a world where the invisible is not only possible but is an integral part of the very structure of the universe. Curiosity and the desire to understand what we cannot see propel us forward. And although we sometimes find ourselves with more questions than answers, that is precisely what makes scientific exploration so exciting. Science continues to challenge our understanding, and each discovery brings us one step closer to unveiling the mysteries of the cosmos. Have you ever stopped to think about how many worlds might be spinning in the vast universe hidden from our view? The search for exoplanets, those planets that orbit distant stars, is a fascinating topic that leads us to explore the unknown. Although there are thousands of planets that we have managed to identify, many of them remain invisible, waiting to be discovered. But how do we know they are there if we cannot see them? The answer lies in the ingenious techniques that scientists have developed over the years. For example, one of the most effective strategies is called the transit method. Imagine you have a lighthouse on the horizon. If a ship passes in front of it, the brightness of the lighthouse will briefly decrease. Similarly, when an exoplanet passes in front of its star from our perspective, it blocks a small fraction of that star's light. By analyzing the light that reaches us, astronomers can detect that small dip in brightness and thus infer the existence of a new planet. However, this raises an intriguing question. What about planets that do not cross in front of their star? How do we find them? This is where another method comes into play: radial velocity. This approach is based on the principle that a planet not only orbits its star, but also exerts a gravitational force on it. This causes the star to move slightly, as if it were dancing. By observing the light spectrum of the star, scientists can detect changes in the wavelength of the light, indicating that the star is moving toward or away from us. Through this movement, we can deduce the presence of invisible planets. What about exoplanets that are too far away or too small to be detected by these techniques? The answer lies in the collaboration of multiple methods. Space telescopes, like the famous Kepler, have allowed scientists to observe thousands of stars at the same time, looking for patterns and signals that indicate the presence of planets. With each new discovery, new questions arise. Is there life on those distant worlds? What are their atmospheres like? The interest in exoplanets lies not only in their discovery, but also in the diversity of environments they may offer. Some might be similar to Earth, while others could be extremely different. For example, giant gas worlds like Jupiter and rocky planets that could have extreme conditions have been found. This leads us to reflect. If there are so many types of planets, what other secrets does our universe hold? The search for these worlds is not just an exercise in scientific curiosity. It also raises philosophical questions. If there are planets that could harbor life, what does this mean for us? The possibility that we are not alone in the universe has fascinated humanity for centuries. Each new discovery of an exoplanet close to the habitable zone of its star brings us closer to answering this question. Understanding how exoplanets are detected also teaches us about the nature of light and how it can be manipulated. Light is a powerful tool. It allows us to see the world around us, but it can also be a means to discover what we cannot see. Every time we look at the sky, we are looking back in time and revealing the history of the universe. As technology advances, new tools are added to our astronomical toolkit. More powerful telescopes and more sophisticated techniques are in development, which will lead us to discover more invisible planets. But what will happen when we can finally see one of these worlds up close? The prospect of exploring other planets fills us with excitement, but also with responsibility. The search for exoplanets is not just about discovering new worlds, it's about learning to take care of the one we already have. The possibilities are endless. Some scientists believe we could find planets that are not only habitable but may have even developed advanced civilizations. Imagining the existence of beings on other worlds who also look up at the sky, wondering if there is life beyond their own atmosphere, unites us in a profound sense. The search for exoplanets also teaches us about time and distance in the universe. Many of the planets we detect are light years away from us. This means that when we look at them, we are seeing images from the past. It is a reminder of how vast and ancient our universe is and how small we are in comparison. In the end, the search for exoplanets is an adventure that is just beginning. Each discovery leads us to new questions and new possibilities. It challenges us to think about what it means to be human, to question our place in the cosmos, and to prepare for the future, a future where invisible worlds become part of our narrative, where curiosity and the desire to explore drive us forward in the quest for truth. In the vast universe, most of the things we see are just the tip of the iceberg. But what about those phenomena in deep space that remain hidden from our view? There are galaxies that we have never observed, stars that emit light in wavelengths we cannot detect, and mysteries that challenge our understanding. The question that arises is, how do we know they are there, even when we cannot see them? The answer lies in the influence these objects have on their surroundings. For example, imagine a swamp covered in fog. Even though you cannot see the bottom, you know there is life there because you can hear the sounds of animals and see the movement of plants. This is how astronomers detect the presence of distant galaxies. They notice how the gravity of these galaxies affects the light from other nearby stars. This interaction gives us clues about what exists in space, even if we cannot directly observe it. One of the most fascinating examples is the galaxies that lie beyond our own Milky Way. It is estimated that there are billions of these galaxies in the universe, many of which are invisible to our telescopes. But how do we know they exist? Modern astronomical techniques, such as spectroscopy, allow us to study the light that has traveled billions of years to reach us. This light can tell us about the composition, temperature, and motion of these galaxies, revealing secrets that would otherwise remain hidden. Not only galaxies are an enigma, it has also been discovered that there are enormous structures such as filaments of dark matter that stretch across the universe. These structures are so large that we cannot see them directly, but their effect on the gravity and light of nearby galaxies gives us clues about their existence. Can you imagine a cosmic spiderweb connecting everything in the universe? That is precisely the image we have of these invisible filaments. It is surprising to think that although the universe seems empty, it is actually filled with objects and phenomena that we cannot see. Astronomers have used gravitational wave telescopes to detect events like black hole mergers occurring billions of light years away. These waves are like echoes of great explosions that tell us stories about what has happened in the universe even when the objects themselves are invisible. And let's not forget supernovae, stellar explosions that can shine brighter than all the stars in a galaxy for a brief period. Although we can see supernovae when they occur, many times the star that exploded is not visible until it becomes a supernova. This means there are many stars that could be in the process of exploding somewhere in the universe, and we do not know until that brilliant explosion occurs. Galaxies can also hide behind other structures. This phenomenon is called gravitational lensing, and it is as if a distant galaxy is concealed behind a glass that bends light. In these cases, the gravity of an intervening galaxy can amplify the light of the hidden galaxy, allowing us to see it in a way that would not be possible otherwise. Thus, sometimes what appears to be a void in space is actually a masterpiece of gravity hiding a cosmic treasure. At other times, deep space is filled with dust and gas that obscures the stars and galaxies behind it. This dust can be so dense that it is impossible to see through it with visible light. However, when we observe in the infrared, we can see through this dust and discover a hidden universe that is invisible in other wavelengths. It's as if we have a flashlight illuminating a dark path, revealing what was hidden. New technologies, such as space telescopes, have revolutionized our ability to observe the universe. Telescopes like Hubble have allowed scientists to look beyond our limitations, and with each observation, we discover more about what exists in deep space. How many more surprises await us in this vast darkness? Additionally, radio astronomy gives us another window to the invisible. By studying the radio waves emitted by certain phenomena, such as pulsars or quasars, we can gather information about objects that do not shine with visible light. Thus, scientists can listen to the universe and learn its secrets in a way we never imagined. Deep space also holds mysteries about the formation of large-scale structures. Computer simulations have helped astrophysicists understand how galaxies form and evolve in a universe that at first glance seems empty. Each new simulation brings us one step closer to understanding how these invisible structures play a fundamental role in the history of the cosmos. Finally, the role of cosmology in our understanding of the invisible cannot be overlooked. Through the study of cosmic background radiation, which is the echo of the Big Bang, scientists can trace the history of the universe and its expansion. This phenomenon, which manifests as a faint glow in the background of space, speaks to a time when the universe was extremely young and hot. The search for the invisible in deep space is a fascinating journey that leads us to question our understanding of the universe. Each discovery reminds us that what we cannot see often has a profound impact on what we can observe. Human curiosity has driven us to explore the unknown, and every answer we find opens the door to new questions, keeping the flame of exploration alive. In this vast cosmic ocean, the invisible is, in fact, part of the story we are eager to unveil. What if I told you that there are stars in the universe whose light we have never been able to see? Even though we spend our lives looking at the sky, there are many mysteries in the vastness of the cosmos that remain hidden from our eyes. The light from many distant stars may not reach us at all, and this is due to a combination of fascinating factors that invite us to explore the infinite. Most stars shine with light that travels through space, but some are so far away that their light simply hasn't had time to reach Earth. To understand this, imagine you are in a giant stadium where the floodlights illuminate the field. If you move far enough away, those same floodlights may appear dimmer and dimmer until you can no longer see them at all. In the universe, distance plays a crucial role, and there are stars whose light has been traveling for billions of years just so that now we here on Earth cannot perceive it. The expansion of the universe is another factor that complicates the visibility of stars even further. Since the Big Bang, the universe has been constantly expanding, which means that some stars are moving away from us at incredible speeds. This causes a phenomenon known as redshift, where the wavelengths of light from those stars are stretched, becoming longer and often invisible to our eyes. One could say that the light that was once bright and clear becomes a distant echo, fading into the vast ocean of space. What about the stars that are on the edge of our understanding? There are stars that emit light in infrared wavelengths, which are invisible to the human eye. This type of light is like the heat you feel when you get close to a stove. You feel it, but you don't see it. Younger and cooler stars, for example, often fall into this range of light. Even though we cannot see them directly, special telescopes can capture those wavelengths and reveal their existence to us. Thus, even though we do not see them, we know they are there, shining and existing in the cosmos. Our own sun is a star that also emits light in infrared wavelengths. However, the Earth's atmosphere acts as a filter, blocking much of that light. This means that there are a number of stars that could be shining in infrared, but we could never see them without the help of the right technology. In this sense, infrared telescopes become our eyes in a universe full of hidden lights. As we continue to explore, it is interesting to consider how many stars we have missed along the way of our observations. Some stars may have exploded in supernovae eons ago, but their light has not yet reached us. This concept of light traveling through time is astonishing. In a way, we are observing the past of the universe. When we look at the sky, we are not just contemplating stars, but also stories from billions of years ago. Galaxies also play a crucial role in this narrative. the light from stars in distant galaxies can be affected by the gravity of other galaxies along the way. This phenomenon, known as gravitational lensing, can make some stars appear brighter or even multiply. In this sense, the universe is a great game of mirrors where gravity acts as a master illusionist, altering what we see and what we do not. Now, what if I told you that there are stars that never formed at all? There are theories about dark stars, which are massive objects that do not emit light but may have played an important role in the formation of structures in the universe. Although we can never see them, their influence is felt in the way galaxies and stars are organized. This leads us to the conclusion that even in invisibility, there is a cosmic architecture that continues its course. And we cannot forget the stars that are in the process of dying. Stars that become black holes, for example, cease to emit visible light and become entities that are very difficult to detect. However, their presence is felt through their gravitational influence on their surroundings. It is fascinating to think that in the life cycle of a star, death can be a new beginning, but for us, its light no longer exists. The search for stars that we cannot see also drives us to look forward. With the development of new technologies and telescopes, astronomy is constantly evolving. Every day, new phenomena are discovered that challenge our understanding of the universe. Human curiosity is insatiable, and with each discovery, we get a little closer to unveiling the secrets of what is hidden. Finally, let us reflect on the meaning of the invisible. In a vast and ever-changing universe, what we cannot see is often just as important as what is in front of our eyes. The stars that do not shine for us remind us that there is so much more in the cosmos than we can perceive. The search for the invisible is not only a scientific exercise, but also an exploration of our own curiosity and desire to understand the world around us. So the next time you look at the starry sky, remember that there are many lights we have yet to see, but that are waiting to be discovered. The universe is full of surprises, and each hidden star is an invitation to continue exploring the unknown. The idea of hidden dimensions may seem like something out of a science fiction novel, but in the world of modern physics, it is a fascinating concept that invites us to expand our understanding of the universe. What if I told you that, in addition to the 3 dimensions we know, height, width, and depth, there are more dimensions that we cannot perceive with our senses? This is a mystery that has intrigued scientists for decades and could completely change our view of the cosmos. Imagine a world in 2 dimensions, like a sheet of paper. The inhabitants of this 2-dimensional world can only move back and forth, and they have no idea what is above or below. If a 3-dimensional object, like a sphere, were to pass through this world, they would only see a circle that appears and disappears. What they cannot understand is that there is a 3rd dimension that is completely foreign to them. Similarly, we may be surrounded by additional dimensions that we cannot see or experience, but that influence the reality we know. String theory, a pillar of theoretical physics, suggests that there are up to 10 or 11 dimensions. But why don't we perceive them? The answer may lie in how these dimensions are curled up or compacted. It's like having a tube of pasta. If you look at it from one end, it appears to be a 1-dimensional object. But if you observe it from a different angle, you can see that it has a 3-dimensional structure. In the same way, these hidden dimensions may be present, but they are too small for us to detect. The concept of additional dimensions is not only intriguing, but could also help solve some of the great mysteries of physics. For example, what is gravity? In our 3-dimensional world, gravity is a force that attracts objects to each other. However, there are questions that remain unanswered, such as why gravity is so weak compared to other fundamental forces. This is where hidden dimensions could offer a solution. They could act as a hiding place for gravity, dispersing it across these additional dimensions and making it appear weaker in our world. When considering the implications of these dimensions, one cannot help but wonder, could we travel through them? Could there be pathways that allow us to connect different points in the universe? The idea of a bridge through hidden dimensions has been explored in science fiction, but it also has its roots in theoretical physics. Some theories suggest that if we manage to understand and manipulate these dimensions, we could even achieve a type of space travel that we currently consider impossible. Hidden dimensions also challenge our understanding of reality itself. If there are more dimensions, how do they affect our perception of time and space? Some theories suggest that time may not be a straight line, but could have multiple directions in these additional dimensions. This would completely change our way of viewing the past, present, and future. The idea of hidden dimensions is also related to the search for a unifying theory of the forces of nature. Throughout history, scientists have tried to find a theory that combines gravity, electromagnetism, and nuclear forces. Additional dimensions could be the key to understanding how these forces relate to each other on a deeper level. By knowing how they interact in dimensions beyond what we can see, we might be closer to unraveling the secrets of the universe. One question that often arises is, what about beings that could inhabit these hidden dimensions? If they exist, what would they be like? Perhaps these beings could perceive realities that we cannot even imagine. They might be observing us from a place we cannot reach, and their existence could challenge everything we know about life and consciousness. In this context, it is fascinating to consider how quantum physics intertwines with the idea of hidden dimensions. The duality of particles and waves, as well as the superposition of states, are concepts that already tell us that reality is not as simple as it seems. Could it be that these additional dimensions are the stage where these strange phenomena occur? Perhaps the key to understanding quantum mysteries is hidden in these dimensions that we cannot yet see. As technology advances, scientists are developing more sophisticated tools to investigate these theories. Particle accelerators like the Large Hadron Collider are designed to explore the fundamental properties of matter and energy. As particles collide at speeds close to the speed of light, they are expected to provide clues about the existence of hidden dimensions or even about the nature of gravity. The exploration of hidden dimensions also faces philosophical challenges. If there are more dimensions, what does that mean for our understanding of reality? Are we willing to accept that what we consider real is just a small fraction of what truly exists? These questions lead us to reflect on our place in the universe and our role in the grand scheme of things. In conclusion, hidden dimensions are a fascinating concept that not only expands our understanding of the universe but also challenges our perception of reality. They invite us to question what we know and to explore the unknown. As we continue to investigate and discover, we are likely to find answers to questions we have only just begun to formulate. The search for these dimensions could be one of the greatest achievements of science. And perhaps one day, they will reveal secrets that will change our view of the cosmos forever. Curiosity is the spark that drives us to keep exploring, and perhaps in the vast universe of the invisible, we will find more than we ever imagined. Relativity is one of those concepts that may seem complex, but in reality, it can be understood with some simple analogies. Imagine that the universe is like a gigantic spider web. Each thread of this web represents space and time, intertwined in such a way that any movement at one point can influence distant points. How does this relate to what we see, or rather to what we do not see? When we talk about relativity, we refer to how gravity affects our perception of the universe. For example, think of a train moving at high speed. If someone is inside the train, they can see the landscape passing by quickly. However, for an observer at the station, the train is moving at a different speed. This phenomenon applies to objects in space. The gravity of a massive object, like a black hole, can bend the light that passes near it, creating a kind of lens that distorts our view of what is behind. What if I told you that this distortion can make us see objects that we otherwise could not detect? The light from a star can be deflected by the gravity of a nearby galaxy, allowing us to glimpse its existence, even if it is hidden behind that galaxy. Thus, the universe shows us a kind of optical magic where the invisible becomes visible thanks to the force of gravity. In this sense, relativity teaches us that gravity not only affects massive objects but also modifies space-time itself. Imagine that space is like a yoga ball and that gravity is a heavy ball that you drop onto it. The ball creates a dent that distorts the surface, and any object that passes nearby will fall toward the dent. This is how stars and planets move in the universe, being influenced by the gravity of other bodies. But how can we apply this understanding of relativity to explore what we cannot see? Let's think about stars. Some of them are so far away that the light they emit takes millions of years to reach us. Over time, that light can be affected by the gravity of other objects along its path. This means that even if a star is hidden behind another, we can detect it thanks to the way the light curves. It's like having a flashlight in a dark room and someone else in the room is holding a mirror that reflects the light toward you. You can see the light, even if you cannot see the flashlight directly. Relativity also leads us to question the nature of time. Is time the same for everyone? The answer is no. When an object moves at high speed, time for that object slows down compared to a stationary observer. This phenomenon, called time dilation, is crucial for understanding how invisible objects can influence the universe. For example, if we traveled close to the speed of light, we might experience a different time than our friends on Earth. This suggests that time is more flexible than we imagine. Imagine then that there are regions of space where gravity is so intense that even light cannot escape. These are black holes, and although we cannot see what is inside them, we can observe their influence on nearby stars. By studying how these stars move, we can deduce the presence of something massive and hidden. It's a game of cosmic detectives where each clue brings us closer to the truth. Moreover, relativity helps us understand the concept of events. In the universe, events do not occur in isolation. Every action has a reaction, and the way objects interact with each other can reveal information about the invisible. For example, when two galaxies collide, we can not only observe the light from the stars that are affected, but also detect the gravitational waves they generate. These waves are like echoes in space-time, telling us stories about the events that have occurred. Relativity also raises intriguing questions about the nature of reality. If space and time are intertwined, what does this mean for our understanding of existence? If an object can seem to be in one place and, at the same time, not be there, then what is the true nature of visibility? This kind of questioning leads us to reflect on how we perceive the world around us. Furthermore, the theory of relativity has been fundamental for the development of modern technologies. For example, satellite navigation systems like GPS must take into account the effects of relativity to function accurately. Without this understanding, we could lose our location in the world, demonstrating that the invisible has a real impact on our lives. When thinking about relativity, it is important to remember that it is not just about equations and complex theories, but about how these ideas transform our understanding of the universe. They push us to explore the unknown and question our beliefs about reality. Each discovery brings us one step closer to unraveling the mysteries of what is invisible. Ultimately, relativity is a reminder that there is much more in the universe than we can see. Often the invisible is just as important, if not more so, than the visible. It invites us to look beyond what is directly in front of us and explore the connections and links that shape everything we know. This journey through relativity prepares us to delve into a universe full of hidden wonders, where every star, every black hole, and every gravitational wave can tell us a story. The next time you look at the sky, remember that behind every twinkling light, there may be a world of invisible phenomena waiting to be discovered. Telescope technology has been one of the most revolutionary tools in the history of science, transforming our understanding of the universe. But what makes a telescope so special? Essentially, it is like an enhanced eye, capable of capturing light that our eyes cannot see. Think of it this way. If your eyes are like a basic camera, telescopes are like high-definition cameras that can reveal hidden details in the vast night sky. Throughout the centuries, humans have looked up at the stars, wondering what lies beyond our planet. The first major breakthrough came with Galileo's telescope. This small instrument allowed scientists to observe the craters of the moon and the moons of Jupiter, opening a new chapter in astronomy. But what about the stars and objects we cannot see? This is where telescopy becomes even more fascinating. Modern telescopes have evolved to detect different wavelengths of light. While our eyes see only a small part of the electromagnetic spectrum, telescopes can capture light in the infrared, ultraviolet, and even radio waves. Imagine you are at a concert and want to hear not only the music but also the whispers of the audience. Each type of telescope acts like a different microphone, capturing sounds that our ears could not perceive. Did you know that most of the stars we see in the sky are just a fraction of what actually exists? Many of them are surrounded by dark matter or are so faint that they escape our view. Telescopes, by being able to capture more light, allow us to see beyond the visible. For example, some telescopes in the Atacama Desert in Chile can see galaxies that are billions of light years away. This is not only impressive, but also changes our understanding of space and time. Telescopy has also been key to discovering exoplanets, those worlds that orbit stars outside our solar system, using techniques like transit, where the light from a star briefly dims when a planet passes in front of it. Astronomers can infer the existence of these invisible bodies. It's like watching someone hide behind a door, even though you can't see them. You know they are there. Now let's talk about black holes. These mysterious objects are so dense that their gravity traps everything around them, even light. However, telescopes cannot see them directly, but they can observe how they affect nearby stars. It's like looking through a kaleidoscope and noticing that some pieces seem to move strangely. That is the gravitational influence of a black hole that you cannot see, but you know is there. The importance of technology in telescopy cannot be overstated. Each new advancement, from space telescopes like Hubble to next-generation telescopes, allows us to explore the universe in ways that were previously unimaginable. Can you imagine looking back in time, seeing galaxies as they were billions of years ago? With the right telescopes, that is exactly what we do. Atmospheric interference is also a challenge. Earth's atmosphere can distort the light that reaches our telescopes. That's why many astronomers have decided to place their instruments in space where the view is clear and unobstructed. It's like trying to watch a movie through a dirty window. The view is much better when you get away from atmospheric pollution. Sometimes the light that reaches us can be very faint due to distance. Telescopes can combine the light from multiple objects to make the invisible visible. This process, known as interferometry, allows us to observe details that would otherwise be undetectable. Imagine putting together different pieces of a puzzle to complete the full picture. The future of telescopy is bright, full of possibilities. Telescopes are being developed that can see in even more complex wavelengths, with the hope of discovering new forms of matter and energy. Next-generation telescopes are designed to explore the first stars and galaxies that formed after the Big Bang, providing an unprecedented view of the origins of the universe. Moreover, artificial intelligence and machine learning are beginning to play a crucial role in analyzing telescope data. This technology can help identify patterns and objects that humans might overlook. It's like having an assistant who helps you organize your notes, ensuring you don't miss any important details. Human curiosity is the driving force behind all these innovations. It pushes us to build better tools and seek answers to increasingly complex questions. Telescopy, at its essence, is an expression of our desire to understand what lies beyond our reach. Every time we look through a telescope, we are taking another step toward discovering the unknown. Finally, telescopy is not just about observing the cosmos. It is also a reminder of how small we are compared to the vast universe. It invites us to reflect on our existence and our place in the immense fabric of space and time. So the next time you look up at the night sky, remember that each point of light could be a world, a star, or even a black hole waiting to be discovered. Telescopy offers us not only a view of what is out there, but also a window into our own curiosity and desire to explore. Gravity, that force that pulls us toward the ground and keeps planets in orbit, plays a fundamental role in our understanding of the universe. But did you know that this same force can also reveal objects we cannot see? In the vast ocean of space, there are entities that remain hidden from our view but leave traces in the fabric of space-time. How can something invisible have such a significant impact? Let's dive into this fascinating intersection between gravity and invisibility. To understand this, it's helpful to think of a calm lake. When we throw a stone into the water, waves are generated that propagate in circles. Now imagine that instead of a stone, there is a massive object, like a black hole. Although the black hole itself is invisible, its enormous gravity causes distortions in the water of the lake, revealing its presence through the waves it generates. In space, something similar happens. Black holes, for example, do not emit light and are therefore difficult to detect. However, their influence is undeniable as they affect the trajectory of stars and gas around them. Have you ever wondered why some stars seem to move strangely in the sky? This may indicate the presence of a massive object, perhaps a black hole or a star that we cannot see. The gravity of these invisible objects pulls on nearby stars, altering their orbits. Thus, even though we cannot see the black hole itself, we can infer its existence through the behavior of the visible stars around it. Gravity also acts similarly in the context of galaxies. Imagine a series of butterflies flying in a garden. If one of them is near a large rock, its flight will be affected by the gravity of the rock, even though it does not move. In the universe, galaxies are like those butterflies, and massive objects such as dark matter or black holes act as invisible rocks that affect their trajectories. By observing how galaxies move, astronomers can deduce the presence of this dark matter, which, although we cannot see, is crucial for the structure of the universe. The influence of gravity doesn't stop there. It can also manifest in the curvature of light. When light from a distant star passes near a massive object, its path bends, a phenomenon known as gravitational lensing. So, even though the light from that star may not reach us directly, its path is altered by the gravity of a hidden object. This not only allows us to see objects that would otherwise remain invisible, but it also provides information about the mass and nature of those objects. In this sense, gravity can be considered a detective that reveals the hidden. Through its effects, we can build a map of what exists in the universe, even if some of those entities do not emit light. This concept extends to other areas, such as the detection of planets orbiting distant stars. Many of these exoplanets are not directly visible, but their gravity affects the stars they orbit. Astronomers can notice the small movement of the star, a result of the planet's gravitational pull, and thus deduce its existence. And what about galaxies that seem to be forming a group? Gravity also plays a key role here. When many galaxies cluster together, gravity pulls them toward each other, creating what is known as galaxy clusters. Although some of these galaxies may be too faint to be seen, the gravitational influence they exert on other galaxies and on the light passing nearby can be detected. In this way, astronomers can study the behavior of these invisible galaxies and understand how they assemble in the universe. The relationship between gravity and invisibility also extends to Einstein's theory of relativity. According to this theory, gravity is not just a force acting at a distance, but a curvature of space-time. This means that massive objects not only affect other objects through gravitational force, but also alter the very fabric of space and time. This radical idea transforms our understanding of what it means to see. Is it possible that what we consider invisible is merely a manifestation of this curvature? But gravity not only reveals what is beyond our sight, it can also be an indicator of phenomena in our own world. For example, on Earth, gravity affects ocean currents and the atmosphere, influencing the climate. Thus, gravity connects us not only with the cosmos, but also plays a crucial role in our daily lives. In the realm of research, scientists use gravity as a tool to explore the unknown. Experiments and observations allow for a better understanding of how invisible objects behave under different conditions. As we improve our observational techniques and instruments, our ability to detect what is hidden expands. What was once a mystery now becomes a subject of study and exploration. Gravity, then, is not just a force. It is the thread that connects the visible with the invisible, It reminds us that just because we cannot see something does not mean it does not exist. The ongoing quest for answers to intriguing questions about the nature of the universe, dark matter and black holes invites us to keep our curiosity alive. Thus, in the vast universe there is much that we have yet to discover and many more invisible stars waiting to be revealed. In a world where the visible seems to reign, there is a hidden kingdom, one that unfolds before our eyes without us realizing it. We are talking about microbial life, a vibrant universe of beings that are invisible to the human eye but play a fundamental role in the functioning of our planet. Have you ever wondered what happens in the soil you walk on, or in the air you breathe beyond what you can see? It is a world full of wonder and mystery, where microorganisms perform essential tasks that sustain life as we know it. Most of us associate life with animals, plants, and beings that we can perceive at a glance. However, the true protagonists of this story are bacteria, viruses, and fungi, creatures that inhabit every corner of our planet. There are trillions of these organisms, and their diversity is so vast that it is hard to imagine. From the depths of the ocean to the highest mountains, they are present in every drop of water, in every corner of the soil, and in our own bodies. What role do these tiny beings play in our ecosystem? The answer is fascinating. Many of them are decomposers, which means they break down dead organic matter, releasing essential nutrients that are recycled in the soil. Without these creatures, the world we know would be covered in waste and life could not thrive. Think of it as an efficient natural recycling system where each small organism has its specific function. The relationship between microorganisms and plants is equally intriguing. Some bacteria and fungi associate with plant roots, helping them absorb water and nutrients from the soil. This symbiotic bond is essential for the healthy growth of plants and therefore for food production. Without these invisible allies, our crops would not have the same strength, and our survival as a species would be compromised. Even in our own bodies, microorganisms play a crucial role. In our intestines resides a diverse community of bacteria that help us digest food, synthesize vitamins, and protect us from harmful pathogens. This internal ecosystem is known as the microbiome, and its balance is fundamental to our health. Isn't it surprising to think that despite being invisible, these microbes influence how we feel and our quality of life? How did we come to know about the existence of these invisible organisms? The answer lies in the invention of the microscope. In the 17th century, Anton van Leeuwenhoek was the first to observe and document microorganisms. Since then, science has advanced tremendously, and today we can study these beings at astonishing levels. Thanks to modern technology, we have been able to explore the DNA of microorganisms and discover new species that were previously completely unknown to us. The exploration of microbial life is not limited to our planet. Scientists are investigating the possibility of microbial life existing on other planets such as Mars or the icy moons of Jupiter and Saturn. What implications would this have for our understanding of life in the universe? Imagine if we found microorganisms in another world. This could change our perspective on life and the adaptability of organisms in extreme environments. But what about microorganisms that cause diseases? It is true that some of them can be harmful to our health, but even here we can find a balance. The presence of pathogenic microorganisms in nature also plays a role in the evolution and resistance of species. The study of these organisms helps us develop treatments and vaccines that save millions of lives each year. Thus, what initially seems like a challenge becomes an opportunity for learning and growth. In the world of biotechnology, microorganisms are valuable tools. They are used to produce fermented foods, medicines, and biofuels, among others. Bacteria are employed in the production of insulin, and fungi are fundamental in the making of beers and breads. The ability to manipulate these organisms has led to significant advances in science and industry, highlighting the importance of what we cannot see. The story of microbial life also teaches us about the interconnectedness of all forms of life. Often we tend to think of living beings as independent entities, but the reality is that we are all interrelated. The health of the soil, water, and air, as well as the health of microorganisms, is essential for the well-being of all living beings. This network of relationships reminds us that although we cannot see all the actors, each plays a crucial role in the dance of life. As we explore the world of the invisible, a challenge presents itself. How can we protect and conserve these microbial ecosystems? Pollution, overuse of antibiotics, and climate change threaten their existence. Education and awareness are fundamental to preserving this balance. By understanding their importance, we can make more informed decisions about our impact on the environment. Microorganisms, although invisible, are a testament to the complexity and wonder of life. They remind us that the world is full of surprises, even in the most unexpected places. As we continue to explore this invisible kingdom, we embark on a journey of discovery that connects us more deeply with the world around us. The next time you think about life, remember that there is an entire universe of beings that, although you cannot see, are essential for our existence and for the functioning of the planet. Thus, invisibility is not a limitation, but an open door to exploration and wonder. Invisibility technology has been a recurring theme in science fiction, where characters like superheroes or spies use gadgets that allow them to disappear in plain sight. But what if I told you that in real life we are already taking steps toward the creation of invisible objects? The idea of being invisible has fascinated humanity for centuries, and now, thanks to advances in science, we find ourselves closer to it than we could have imagined. In simple terms, invisibility refers to the ability of an object to not be seen by the human eye. But how is this achieved? The key lies in the manipulation of light. When light hits an object, it can be absorbed, reflected, or transmitted. Invisibility occurs when an object is able to guide light around it, so that it does not collide with it and therefore is not seen by our eyes. This phenomenon is called optical camouflage, and some interesting advancements have already been made in this field. Imagine an object that, instead of being a barrier to light, acts like a river that flows around it. This is what scientists have been trying to replicate using special materials known as metamaterials. These materials are designed to have optical properties not found in nature. Through a combination of advanced techniques such as the use of nanoscale structures, layers can be created that bend light. Thus, an object could become invisible to certain wavelengths of light. One of the most well-known examples of this technology was presented in 2011 when researchers at Duke University managed to make a small, three-dimensional object invisible at certain light frequencies. Although we are still far from being able to make large objects invisible, these experiments show us that invisibility is not just a dream, but what are the applications of this technology in the real world? The ability to make objects invisible could have a significant impact on sectors such as defense and security. Imagine a military vehicle that can become invisible to enemy radars. This would not only change the way wars are fought, but could also save lives. Additionally, in the civil realm, we could think of applications in art, where sculptures could be hidden and revealed at specific moments, creating stunning visual experiences. However, invisibility goes beyond what we see at first glance. The technology also extends to radio waves and other forms of radiation. This means that we could not only hide objects from sight, but also interfere with detection by devices that operate with these waves. Can you imagine a world where personal privacy can be effectively protected? Invisibility could offer new solutions to surveillance and monitoring issues, despite the promises this technology presents. There are also ethical challenges. The ability to hide objects raises questions about the use and abuse of this technology. If someone can become invisible, how can we ensure that they do not use that advantage for malicious purposes? The line between protection and violation of privacy becomes blurred, and it is crucial for society to explore these aspects before moving further in this direction. Invisibility also leads us to reflect on the way we perceive the world. When an object becomes invisible, it not only hides from our view, but also changes our understanding of reality. It reminds us that there is much in the universe that we have yet to discover, and that our vision of the world is, in many ways, limited. The layers of what is visible and what is not are more complex than we might have imagined. Research in invisibility is in its infancy, but scientists are optimistic about the future. Each advancement in this area opens new doors to creativity and innovation. The question that remains is, how far will we go? Will we one day see large, everyday objects become invisible? The answer is uncertain. But human curiosity to explore the unknown is undeniable. On this path toward invisibility, we find an echo of humanity's quest to understand and master nature. Science is advancing by leaps and bounds. And although it may seem that invisibility is just a concept from science fiction, the future could surprise us all. The exploration of the invisible not only challenges our perceptions, but also invites us to question what we believe is possible. So the next time you think about invisibility, remember that it is not just a magic trick. It is the result of years of research and a testament to human ingenuity. As we continue to advance in this fascinating frontier of science, let us remember that perhaps what is invisible today could be the first step toward even more astonishing discoveries tomorrow. The search for the invisible is underway, and who knows what wonders await us around the corner. Invisibility has captured the imagination of humanity since time immemorial, from the myths of heroes wearing cloaks that made them invisible to modern scientific experiments. The concept of the invisible raises profound questions about the nature of our reality. What does it mean for something to be invisible? Is it merely a matter of not being able to see it, or is there something more that lies behind that lack of visibility? When considering the invisible, we are invited to reflect on the limits of our perception. Most of us assume that what we cannot see does not exist. However, science has shown that reality is much more complex. There are phenomena, objects, and forces that, although we do not see them directly, have a profound impact on the world around us. How can we reconcile this discrepancy between what we see and what we know exists? The philosophy of the invisible leads us to question the validity of our senses. If what is not visible can be real, what other realities might be occurring around us without our awareness? This dilemma invites us to expand our understanding of the world and to recognize that reality may be richer and more varied than our eyes can perceive. In this context, invisibility is not just a limitation, but a window to the unknown. In the realm of science, invisibility teaches us about the humility of human knowledge. Throughout history, we have discovered that many of our theories about the universe have changed as we have obtained new data. Dark matter and dark energy are clear examples of how what we cannot see can be crucial to understanding the structure of the cosmos. How many other truths might be waiting to be discovered? The exploration of the invisible also raises ethical questions. If there are beings or phenomena that we cannot perceive, do we have a responsibility to seek their existence? Microbial life that we cannot see with the naked eye, for example, is fundamental to our ecosystems. How can we justify our indifference toward what we do not see? The philosophy of the invisible invites us to consider the interconnectedness of all forms of life, visible and invisible. In a broader sense, invisibility also confronts us with our own limitations. It forces us to accept that there are many things we cannot fully understand. Quantum physics, with its perplexing principles, challenges our intuitions about reality. Is it possible that there are hidden dimensions or parallel realities that we simply cannot perceive? What implications would this have for our understanding of time and space? The search for the invisible also taps into the innate curiosity of human beings. Since ancient times, we have looked to the stars, wondering what else is out there. The exploration of deep space and the search for exoplanets are examples of how humanity strives to discover what it still cannot see. What treasures might be hidden in the darkest corners of the universe? As we delve into the concept of invisibility, we also find a fertile ground for creativity. Artists, writers, and filmmakers have explored the theme of the invisible in diverse ways, posing questions that go beyond science. Invisibility becomes a symbol of the unknown, of what we cannot control, and of what we may never fully understand. To what extent can our imagination expand our understanding of reality? The philosophy of the invisible also invites us to consider the relationship between what we know and what we believe. Often, our beliefs are shaped by what we can see and experience. However, advances in science have shown us that the visible is only a small part of a much larger whole. How are our beliefs affected by what we cannot see? Are we willing to accept that there are truths beyond our perception? Ultimately, invisibility can be a catalyst for innovation. The search for technologies that enable objects to become invisible is advancing. From optical camouflage to new materials, this has not only military applications but could also revolutionize medicine, architecture, and other fields. What advancements can we expect if we learn to master the invisible? In every corner of our existence, the invisible reminds us that there is much more than what we perceive. This reminder invites us to continue exploring, questioning, and learning. Human curiosity is insatiable and drives us to ever deeper depths of knowledge. Wouldn't it be fascinating to imagine a future where the invisible becomes part of our everyday reality? As we look ahead, the challenge of the invisible pushes us to be more open and receptive. Science, philosophy, and creativity can intertwine to offer us new ways of understanding our reality. Invisibility is not just an abstract concept, but an invitation to explore the unknown and embrace the complexity of the universe. Reflecting on the invisible can also lead us to a sense of wonder and awe. By recognizing that there is much more beyond what we see, we begin to appreciate the beauty of the unknown. This sense of wonder can inspire us to be more aware of our connection to the universe and our role within it. How might this perspective change the way we live and relate to the world? Finally, it is crucial to remember that the search for the invisible is also a search for meaning. In a world that often seems chaotic and confusing, exploring what we cannot see gives us the opportunity to find meaning in the unknown. The philosophy of the invisible not only challenges us to question what we know, but also offers the possibility of discovering new truths that can enrich our lives. The exploration of the invisible is a fascinating journey that invites us to delve into a universe full of secrets. We have talked about things we cannot see but which are fundamental to understanding the cosmos, matter, and our own lives. But why is this so important? The answer lies in human curiosity. Since time immemorial, we have looked to the sky and wondered what lies beyond the obvious. Every discovery about what we cannot see transforms our understanding of the world. The existence of dark matter and dark energy, for example, shows us that the universe is much more complex than we can grasp with our senses. Can you imagine that around 95% of the universe is invisible to us? This leads us to reflect on our own perception. If so much of what surrounds us is unobservable, what other realities might be right in front of us waiting to be discovered? Black holes, those mysterious and powerful phenomena, are also a reminder that there are forces operating beyond our immediate understanding. We often think about what we can observe, but the true wonder lies in what we cannot see. How can objects that do not emit light attract so much and affect everything around them? The gravity of a black hole is a powerful reminder that the invisible can have a monumental impact. In our own solar system, there may be planets and moons that we have yet to detect. What stories could those hidden worlds tell if we had the ability to see them? The search for new celestial bodies leads us to question the possibility of life beyond our planet. The exploration of the unknown has always been a driver of innovation and discovery. Stars that shine in the infrared are another example of how our sensory limitations prevent us from seeing the entirety of the universe. What if I told you that there are many more stars than we can perceive? Each of them could be a beacon of information, a piece of a cosmic puzzle waiting to be assembled. The cosmic microwave background radiation, that faint light that permeates the universe, speaks to us of the first moments after the Big Bang. This type of radiation, although invisible, is key to understanding how our universe formed. How is it possible that something so ethereal and distant provides us with answers about our origin? Diving into the subatomic world, we realize that many particles are invisible to the naked eye, yet they are fundamental to matter itself. Every atom that makes up our being has a hidden world, a miniature universe that operates on its own level. What other surprises does this tiny realm hold for us? Quantum physics, with its strange and seemingly contradictory principles, challenges our perception of reality. How can something be and not be at the same time? This type of paradox leads us to question what we understand by visibility and reality. Science, at its core, is a continuous challenge to what we think we know. What about exoplanets? The search for worlds beyond our solar system has revealed that, although many are invisible to the naked eye, their effects can be noticed. The transit technique, where a planet blocks the light of a star, is a perfect example of how the invisible can be detected. Who knows how many worlds might be orbiting distant stars, waiting for us to discover them? The exploration of deep space also leads us to reflect on the vastness of the universe. There are galaxies so distant that their light has not yet reached us. The expansion of the universe causes many of them to escape our view. What stories do those galaxies hold, and what secrets could they reveal if we had the right equipment to observe them? The phenomenon of relativity reminds us that visibility is not just a matter of light. The way we experience time and space can alter what we consider visible. How does this affect our perception of reality? Science teaches us that what we can see is only a fraction of what exists. Telescopy has revolutionized our ability to detect the invisible. Every technological advance brings us one step closer to understanding our universe. What discoveries await us in the future as we continue to develop new tools? Human curiosity is insatiable, and every answer raises new questions. Gravity, that force that shapes our universe, can also reveal what is invisible. The gravitational effects of massive objects can be detected even if we cannot see them directly. This leads us to reflect on how our limitations can be overcome with ingenuity and observation. Microbial life, although invisible to the naked eye, is fundamental to the balance of our planet. These microorganisms are essential for the health of our ecosystems. What other forms of invisible life might exist in our environment, and what role do they play in our daily lives? Finally, the exploration of invisibility in technology opens a field of possibilities. Research on how to create invisible objects has begun to bear fruit. What applications could these advances have in our daily lives and in the future of science? The philosophy of the invisible invites us to reflect on our understanding of the world. If so much of what exists is invisible, how can we be sure that what we see is all there is? Curiosity and the desire to explore the unknown are engines of our progress. In the vast universe that surrounds us, there is always more to discover. In the end, the search for the invisible is, in essence, a quest for knowledge. Each new discovery brings us closer to the truth about our universe and our place in it. Let us continue to ask questions, inquire and explore, for in curiosity lies the spark of life.